Alright, welcome to part 2 of the AOE effects tutorial. So in the last tutorial we got it set up so that we can kind of see our character's health. Let's go ahead and actually remove this divide by 2 since we want the character to start at full health. Now if we run this, he should be back to full health, which he is. Alright, so now we can kind of start writing the functionality for the AOE effects. And to do that, we want to write this code in a place that's easily accessible from no matter where we are inside of the project, because we want this to be reusable for grenades, for power-ups, for healing abilities, for any type of thing that you want to have it inside of an AOE effect. We want to be able to use this code and not have to rewrite it. So to do that, we need it to be in a place that's accessible from anywhere. And a good place to do that is inside of the game state. So, I already made a game state, but you won't have this, so I'm just going to delete this real quick. Force delete. So inside of your content folder somewhere, just right click and go to blueprint class. And then it's not going to be in this top thing here, so you're going to have to use this drop down. And you want to search for game state and select this. Or sorry, we want to select the game state base if you're doing a single player game. If you're doing multiplayer, you might want to use the game state because this one has, as it says, behaves like a multiplayer match game. But as a single player, so I'm just going to use the game state base. And I'm just going to call this the third person game state. And so we need to actually tell Unreal to use this game state. So we need to open up our game mode, which I believe is inside of the blueprints folder. Yes, it is. So we open this up. And we want to change the game state class to third person game state. Compile and save. All right, so now we can open up, I'm going to close this game mode real quick. So now we can open up our game state, third person game state. And inside of here, we want to add a function. So hit function, and we'll call it spawn AOE. So what this is going to do is whenever this gets called, it's going to spawn that AOE effect based on whatever parameters you pass it. And then whenever it detects a hit, it's going to call an event back in the class that called this to say, hey, we hit something. Now you can go ahead and do whatever you want to do. And that'll make a little bit more sense once we kind of start writing it. But for now, let's just start adding the input parameters. So we're going to want one for the location. So we'll say vector, and we'll call it location. Let me just slide this over a little bit. And then we want one for the radius. So radius, oops, this should be float. And the name should be radius. And then we want another one that's a boolean. And we're going to call this require LOS. And what LOS stands for is line of sight. And so essentially what this bool does is if it's set to true, then we're going to say that this AOE is only going to hit something if the source of the AOE has line of sight to the thing that it hit. So a good example of this is like a grenade. If a grenade goes off on the other side of a wall from you, you don't want the grenade to hit you, even if it's technically very close to you, because there's a wall between you. So you would say the grenade does not have line of sight to the character, therefore the grenade should not damage the character. But for other type of AOE attacks, like maybe a poisonous gas, or maybe like a healing thing that heals all your allies, and you actually want it to go through walls or whatever, then you would say do not require line of sight, and then it will still hit the character even if it doesn't have line of sight. So that's kind of what this boolean's for. And then finally, we want the instigator, or the person that's responsible for spawning the AOE effect. So we'll add a new parameter. We'll select actor, and we'll call this the AOE instigator. And again, this is just who's responsible for spawning it. And then we want, like I said before, we want an event that gets called whenever this function detects that we've hit something. So to do that, we need to create an event dispatcher over here on the left. So we're going to hit event dispatcher, and we'll call this AOE hit delegate. And we want this delegate to take in one parameter. So we'll come up here, make sure you have this selected, come up here, hit new parameter, and then we want it to be a type actor. And we want the name to just be the hit actor, so the actor that it hit. So if we drag this in, and we select the bind option, and we'll hook this up. Then it will give us this little event thing here, and we actually just want to drag this and onto the function, and it'll add the pin, and you can see it adds an input pin. And then if you select it, it will show up over here, and we can just rename it to what we want it to be. So this is going to be the hit delegate. So basically, whoever calls this spawn AOE function is going to pass us an event, and then whenever this function detects that it hits something, it's going to call that event. And the beauty of this is that the person calling this event can then do whatever they want. So you can use this for grenades, and the person can call the event. This function will check to see if it actually hits something, and if it does, then the grenade class can handle dealing damage. But you could also use this for healing. So somebody could call this event, and then when they get the on-hit event, they can then heal. So the person calling this event has full control of what actually happens if the AOE hits something. But the AOE logic is all still the exact same. So it makes it super reusable and very like dynamic. And then finally, we want two more real quick for debugging. So we'll hit this again. And this one's going to be a float. And this is going to be the draw debug duration. So like how long to draw the debug symbols for. And then finally, we want one more for the color of the debug symbols. So we want a linear color. This guy, linear color, and we'll call it the debug color. All right, so now let's go ahead and start writing this function. So the first thing we're going to want is a sequence. So if you hold down S and left click, you can create a sequence. You can also create this by right clicking and just searching for a sequence. It will pop up. So essentially the first thing we want to do is the actual logic to check if we're hitting something. But then after that, we want to unbind from this event. So if we right click and say get hit delegate, which is just this guy over here, we want to call unbind event from AOE hit delegate. And hook that up. And the reason we're doing this is because every time they call this function, we're binding to our event dispatcher over here, whatever they pass to us. So whenever this function exits, we want to make sure we unbind it, so that way they don't keep stacking. All right, so now that it's unbound, we can start writing the actual function. So the first thing we want to check is if the draw debug duration is something greater than 0, because if it's greater than 0, that means that they're trying to that they want to actually see debug symbols. If they pass in 0, then they obviously don't want to see any debug symbols. So we'll say float, or we'll say get draw debug duration, and we'll say float greater than to check if it's greater than. And we're checking if it's greater than 0, so we can just leave that. Then we'll drag off this and create a branch. Hook it up to the thin. So if they are desiring us to draw debug symbols, then we're going to say draw debug sphere. And essentially what we're going to be drawing right here is the sphere that represents the radius of the AOE. So we hook this up to true. And then we just need to fill in these parameters. So the center is obviously going to be, the location that they pass us. So we'll say get location. The radius is going to be the radius that they pass us, so we'll get radius. The segments can basically just be whatever you want. It's just how many segments make up the circle. I'm going to use 16. The linear color is the get debug color. Or sorry, the line color is the debug color. The duration is the get draw debug duration. And then the thickness is like the thickness of the lines. I think 2 is probably a pretty good value for this. All right, so that's just drawing the debug sphere, but we actually want to do collision based off this sphere. So we're going to use the node sphere overlap actors. And what this node is going to do is it's going to take in information about a sphere, and it's going to return to us an array of all the actors that we hit inside of that sphere. And it's really important that we hook this up to this draw debug sphere, but we also hook it up to the false node, so that way it executes regardless of if we're drawing debug symbols or not, because either way, we want to do the algorithm. So we need to pass in a few things here. It wants the position and the radius, which I'm just going to copy these guys because it's the exact same thing. And then it's asking us for the object types. So this is going to be different depending on your project, but if you drag off of this and search for make array, you can see it gives you this little array here where you can add more pins if you want to. But for this tutorial, I'm just going to add the pawn and say only overlap with pawns. But if in your game you want it to overlap with like trees or vehicles and you want it to do damage to that type of stuff as well, then you'll need to add more pins here for the things you want it to hit. But for the sake of this tutorial, I'm just going to say pawns. And then the actor class, we're just going to choose actor, so it encompasses everything. And then the actors to ignore is actually going to be our instigator, because we want to ignore the actor that's invoking the AOE effect. So we'll say make array, and we'll say get AOE instigator, like so, which is just this guy over here, our AOE instigator. And then we want to do a for loop over all of the characters that we hit. So we'll say for each. And then the first thing we want to do is just store this for easy access. So we'll say promote to local variable. And we'll rename this to our current actor. And then we want to check if the thing that we have hit actually implements the health interface. Because if it doesn't implement the health interface, then there's really no reason to go any further, because we can't damage it, or we can't heal it, we can't really do anything to it. So we want to say does implement interface, search for the health interface, make a branch off of this, like so. All right, so at this point we can probably start testing it. We'll just say that if it implements the interface, it gets past all this check, then we're going to call our hit delegate. So we'll drag this in and say call, hook this up to the true, and then the hit actor is our current actor, so we're going to drag that in. So compile and save all this. Back in our third person character, let's come down here. Below our event heal and event damage, let's just add a key input to test this. So we'll say input E, and let's find the E key. There it is, E. So whenever they press E, we're going to spawn some AOE damage effect from the location of the player. So to do that, we need to get our game state. So we'll say get game state, since this is where our spawn AOE function lives. Drag off this, and we'll cast to our third person game state. Hook that up. And then we'll call spawn AOE. And all we need to do now is fill in these parameters. So the location is going to be the location of ourselves. So we'll say get actor location. The radius is going to be whatever we really want it to be. It's just the radius of the attack. So we'll say like 400 maybe. Require LOS we'll set to true, since eventually we're going to want this to require LOS, even though we haven't actually written the code for this yet. We'll just leave it checked for right now. The instigator is our self, so we'll say get reference to self. And now we come to this delegate. So the way you hook up a delegate is you just drag off of it and say add custom event, and it will create a little custom event for you. We'll fill this out in a second. Let's finish filling out these guys. So the draw debug duration, we'll say like 2.5 seconds. And the debug color we'll set to like red or something, since it's a attack, like that. All right, so essentially what's going to happen is, if you're still kind of confused, whenever they press E, it's going to get the game state, it's going to cast it to our third person game state, and then it's going to call this spawn AOE function. And it's taking in all these parameters, and then it's taking in this hit delegate. So whenever this function right here detects that our AOE effect hit a character or something that implements that damage interface, it's going to call this event down here. So we can do inside of this event whatever we want to do. And that's kind of, again, the beauty of this spawn AOE function, is that you can use it for healing, you can use it for damage, you can use it for applying abilities, all sorts of stuff, because the actual functionality of what happens is defined outside of this function. So for right now, I'm just going to say print string. I'm just going to print the name of this actor that we hit, just so we can kind of see it working. So if we come back to our world, and I'm going to hold down Alt and drag off of this guy, just to make a copy. So now we have two guys, and if I press my E key, you can see it spawns this red sphere. And if you look at the top left of the screen, it says third person character 2, because it's printing out the name of that character in front of us, because he's getting hit with our little AOE attack. And you can see if we move away from him and we press E, he's not inside of the sphere, so he doesn't get hit with the attack. Alright, so now let's go back and actually make it so he takes damage. So we come to our third person character. Let's delete this real quick. And to make him take damage is actually really simple. We'll just drag off of our hit actor and type in damage. And we want to use this one right here, which is damage message, because it's calling the damage function on the interface. And we don't need to cast this guy to or we don't need to check if our hit actor implements the damageable interface, because this function already does it for us. So if this event is getting called, then we can just safely assume that this guy implements the damage interface. And then we can pass in however much we don't want to damage him. So if we run this again, I'm just going to pass in 100. If I press E, you can see each time I press E, he takes 100 damage. And if he's outside of the range, then I can press it as much as I want, and he doesn't take damage. And you'll also notice that I, the character, does not take any damage because we're passing in him as the instigator. And if we didn't do that, if I just unhook this and run it, you can see when I press E, I take damage myself. So you can kind of control if you want, the person invoking the AOE effect to also be affected by it or not by whatever you pass into here. All right, but obviously we want to make it so that if there was a wall between these guys, I guess I'll just go ahead and add one real quick. So I'm just going to take this, I'm going to hold down Alt, left click to make a copy, and we'll just make a little wall here between these guys. All right, so now if I go and I press E, you can see he still takes damage, which, again, you might want, but you also might not want. For things like a grenade or an explosion, you don't want this, because you want the explosion to be blocked by the wall. So to make this work, we need to implement this functionality for require LOS, because right now we're just not requiring any line of sight to apply damage. So if we come back here to the right, let's unhook this real quick. So Alt left click to unhook, drag this over a little bit. We want to check if that line of sight is required. So we'll say get LOS or get require LOS. And we can drag off this and make a branch to check if it's true or false. So if it's false, then we just want to go ahead and do what we were doing before because there's no line of sight required. Pretty simple. But if it's true, then we want to do essentially a series of line traces to check if we have line of sight to the character. Now, this is also going to be kind of dependent on your game and what type of things you're trying to hit. I'm writing this code so that it only works for characters and it doesn't apply to like environmental stuff. So you might have to slightly change this if you want it to apply to other things. But basically what we're going to do is we're going to do a series of line traces from the AOE's origin location to the player's capsule. So to do that, we're going to say get current actor, and we're going to cast to character, and then we're going to get capsule component down here at the bottom. And then actually, I'm trying to think if I should do it this way or not, because I don't want to confuse people, because if in your game you're hitting something that isn't a character, then it's not going to work here. But this is more accurate if you're using characters. Here, let's just do it this way. I'm just going to do it live. So maybe a slightly more generic way to do this is, let's drag in this current actor again, and then we're going to say get actor collision, get actor bounds. That's what it's called, get actor bounds. So what this function does is it gets the bounds of the actor regardless of what it is, so that we can know where we need to detect collision for it. And we want to check both of these boxes because we only care about components that have collision associated with them, and we also care about the child components. So what this is going to do is it's going to return to us the origin of the box and the box extents that represent the character's like bounding box. And what we want to do is we want to create a series of line traces. We're going to do one to the center of the character, and then one to each of the corners of the boxes. So we're going to have 8 in total. And I'm actually going to make a little helper function for us to do this. So over here on the left, I'm going to hit a function, and I'm going to call it get box corners. And we can make this private, and we can also make it const as well. So what this event needs to take in is the box and the extent. So we'll take in, actually, yeah, it'll do that. We'll say vector, take in the origin, and then what was the other thing? Takes in the origin and the box extent, yeah. Sorry, where am I? Up here, yeah. Taking the origin and the box extent. Is it extent or extent? It's extent, okay. So from here, we want to create those 9 different points. Again, one inside of the center of the box, and then one on each corner of the boxes. So the origin is our center, which is pretty straightforward. And then our box extent is going to be represent our half, like the half distance on our X, our Y, and our Z. So let me think about how to do this for a second, because I'm doing this live, I'm not copying anything. So let's come over here, select this, and on the right, let's add an output pin as an array, and we'll call this the corners. And then we want to say, or drag off of this and say make array. And then we want to add a total of 9 pins here. So we'll say 1, 2, 3, 4, 5, 6, 7, 8. So we should have an 8 down here at the bottom, which means 9 pins because it starts at 0. And then we just want to add all of the corners of the boxes, including the origin. So the first one we're going to add is the origin, so we'll just say get origin. It's pretty straightforward. And then this part's going to be a little confusing. So the first one we're going to do the top of the box first, all 4 corners of the top of the box, and we're going to do the bottom of the box. So copy this origin, and we'll say vector plus vector, and then vector plus vector, and then we're going to split this guy. And then we want to drag in the box extent, so we'll say get box extent. And then we're going to split this one as well. And we want to hook up the X to the X and the Z to the Z. And then we can hook up this to there. So that's one of our corners. And then we can copy this and paste. And then instead of doing positive X, we want negative X. So we'll just say float multiply by a -1. And we'll hook that up to the X. And then we can copy both of these and paste this. And then we just want to do Y instead of X, so we'll hook up Y instead of X this time. Like that. And then finally we can copy all of these guys. And then we just want to keep it the same, except we want to change Z to -Z on all of them. So we'll just say float times -1. This would be an example of something that's much easier to do in C++. So I'm just going to copy this, that up, and I think I missed one actually. Yeah, this guy. That up, and that up. Okay. And then we just want to connect all these pins. I'm just going to drag this down a little. So just make sure you hook all these up to the make array, and then we should be good. Up, and that up. Okay. Now we have this handy little function that's going to get the corners of our box. So we can come back to our spawn function, spawn AOE function. And off of here, we can just say get box corners, drag this in, hook this up to true, and then we can hook up the origin and the box extents. So this function is going to return to us all the corners of our box. So then we want to do a loop over those. And we want to use the for each loop with break. We want to use this one because we potentially will break out of it early if one of the line traces hits something. Because again, we only we only need to make sure that at least one of the lines hit it to ensure that we have line of sights. So if the first line trace hits the the target, then we don't need to do the other ones. We don't need to waste the CPU on the other ones. We can just break out immediately and say, yeah, we hit. So we'll say for each loop with break. Go ahead and hook that up. And then we're looping over the endpoints. So we want to do a line trace with the array element as the endpoint. So we'll say line trace by channel. The start is going to be the location of the AOE, so we'll say get location. Get location. The endpoint is going to be our array element, like I just said. I'm just going to kind of clean that up. Like that. And then I'm going to use the visibility channel. You might want to define another channel for AoE damage if you're seeing that like tree leaves are blocking AoE damage or something weird like that. But for this tutorial, I'm just going to use the visibility channel. The actors to ignore, again, is going to be our instigator, so we'll say make array. And we'll hook up our get AoE instigator. The draw debug type, we only want to use the draw debug type if our draw duration is set to something other than 0. So we're going to say get draw debug duration, and then we want to check if it's greater than 0, so we'll say float greater than. And then off of this, we're going to do a select, say select. And then if we drag the return value into here, it will automatically change it to what we want. So if the draw debug duration is greater than 0, then we want to draw for duration. Otherwise, we just want to keep it at none. And if we hit this little drop down here, we'll get access to a few more options. The draw debug time, we want to hook up to our draw debug duration, just like so. And I think that is good for the line trace. And then we want to check if the line trace does not hit something. And the reason we want to check if it does not hit something is because, again, we're checking if we have line of sight. So if the line trace does not hit something, then that means we have line of sight because it didn't hit anything. So we'll say not boolean to make this a not. And then we'll say branch that up. So if it did not hit something, then we're safe to say we have line of sight. So we can go ahead and call our AOE hit delegate. So we'll drag this in again, say call, and we'll pass in our current actor. And then we want to break. So we actually want to take this, and we're going to drag over here to the break, and release. And it kind of does it pretty ugly by default, so I'm going to double click here and make some reroute nodes just so it's a little bit more clear about what's going on. Something like this, just so it's kind of obvious to say, oh, it's going back around here and it's breaking. And then just like that, I think we might be done with this little part at least. So again, just to kind of recap what's going on here, because I know this is a pretty big function. So first thing we're doing is we're taking the hit delegate that they passed in, which again, this hit delegate is just an event that they want to be called whenever the AOE hits something. And we're binding to it so that we can call it later. And then we're checking if the draw debug duration is greater than 0. If it is, then we're going to draw a debug sphere for that amount of time, just so they can see what's going on. And then we're doing a sphere overlap, so we're saying, okay, what actors are inside of this sphere that they have passed to us? And then we're looping over all the actors inside of the sphere that we hit. We're checking if they implement the health interface, and if they do, then we're checking if they require line of sight to be hit. Of course, if they don't require line of sight, then at this point we can just go ahead and return and call the AOE hit delegate and say, yep, you got hit. But if it does require line of sight, then we are getting the bounding box of the actor that's inside of the sphere. And we're doing a series of line traces towards the center, towards the top, and towards the bottom of that box to check if any of those line traces have line of sight to the character. And as soon as one of them does not collide with anything, meaning it has line of sight, then we go ahead and we call the AOE hit delegate. So now if we compile, save all this stuff, and we come back here to our third-person character, you can see we have this require LOS checked. So if we come back here and we hit play again, and I press E, you can see that on the right side there, the character's health bar does not go down. And you can actually see all the line traces that are happening. You can see the one that goes to the middle, and you can see the 4 that go to the top, and the 4 that go to the bottom. And none of those are hitting the character. But if I come over here and kind of peek around the corner a little bit, once I get to the spot where I can actually see him from where the AOE damage is spawning from, then you can see he starts taking damage. And this is really nice because, you know, it kind of just makes it dynamic. Grenades just kind of work now. Like, if it explodes, you don't have to worry about if there's a wall there and all this crazy stuff. It'll just kind of work because the line traces will kind of figure it out for you and actually make sure that it has line of sight. And again, if you don't check this checkbox, then we'll just ignore the wall and it will just damage him no matter what. So that's essentially the end of the tutorial, but if anybody wants like more information on how to use this, I'm going to be doing some more examples here, like making a mine and like the cool stuff you saw in the tutorial to show you kind of how you would use this in other situations. And I'm going to be doing that in part 3. So if you kind of want more clarity on what's going on and more examples, then feel free to stick around. Otherwise, hope you enjoyed the tutorial. If you did, please leave a like and subscribe. Thanks.